So example 3 now says cards are drawn from a standard deck of 52 cards without replacement. Calculate the probability of obtaining a king and then another king. So if you just watched example 1 a moment ago, you know that drawing cards and not putting them back will change the probability. All right, so without replacement tells us that this is a dependent. That these are dependent events. So the probability of drawing a king and then another king would be, as we know from the last example, so there's 4 kings in a deck, so there's 52 cards overall, so it's 4 over 52 to draw the first one. But then to draw a second one, well, we've taken one of the kings away, and we've taken one of the cards away. This becomes 3 over 51. And you can just multiply these together and then simplify from there, but I'm going to simplify first just to make this a little bit easier. I'm going to get 1 over 13 times 1 over 17, which equals 1 over 221, which is 0.45%. It's pretty unlikely that you draw 2 kings in a row. But what about a club and then a heart? So club and then a heart. Well, there are 13 of every suit in the deck. But once we've drawn one card, there's one less card to draw. So, and we can simplify this a little bit, because 13 over 52 is a quarter. That makes sense. There's an even number of 4 suits in a deck. But 13 over 51 is a fraction that cannot be reduced. So we're stuck with that one. 204 is 51 times 4, which is 0.064, which equals 6.4%. So a little more likely. Okay, what about a black card, then a heart, and then a diamond? So black card times the probability of drawing a heart times the probability of drawing a diamond. Okay, so there are 26, or half of the deck cards are black cards. We just said there were 13 of each suit, but then each time we draw a card, the number of cards left goes down. And well, we can simplify this a little bit because 26 over 52 is a half, but then like before, these fractions with 13s in them are often hard to reduce. So we get 169 all over 5100, which equals 3.3%. Right, so we had dependent events here, where basically every time we've done something, it changes the probability of that next thing happening. And drawing cards is a really easy or really straightforward example of seeing that.